Look up at the night sky. Take a moment and just look. You see the moon, silver, familiar, patient. You see the planets, Venus, perhaps Mars, perhaps Jupiter, each holding its quiet place among the stars. You see the constellations our ancestors named thousands of years ago. It looks complete. It looks finished. It looks like it has always been this way. But the sky you see tonight is not the sky that once was. Our solar system is not what it used to be. It is older now. Quieter. Emptier. Once, there were more worlds. Once, there were planets where there are now only ruins. Once, there were worlds that lived for a brief time and then were gone. Some collided with the Earth itself and gave us the Moon. Some shattered into a billion pieces and became the asteroid belt. Some were imagined, believed in for centuries, before science gently proved they had never existed at all. And some we are still searching for. Right now. In the cold darkness beyond Neptune. Waiting. This is the story of those worlds. The lost worlds. The dead worlds. The forgotten worlds. The worlds our solar system used to have, and the worlds it may still be hiding. Tonight, we will travel slowly through their stories. We will visit a planet the size of Mars that no longer exists. We will visit a world that astronomers waited 2 centuries to find, only to learn it was never there. We will visit the empty space between Mars and Jupiter, where something enormous may once have lived. And we will reach the very edge of our solar system, where a giant world may still drift, unseen. There is no rush tonight. There is nothing to do, nowhere to go. Just close your eyes, or let them rest gently on the screen. Let your breathing slow. The cosmos is patient. It has waited 4.5 billion years to tell us these stories. It can wait for us a little longer. Welcome to Sleeping Galaxy. This is the story of the lost worlds of our solar system. For 4.5 billion years ago, our solar system was very young. The sun had just been born, a pale, hot infant star, gathering its strength. Around it, a disk of dust and gas slowly cooled. Within that disk, small grains began to clump together. Those clumps became pebbles. The pebbles became boulders. The boulders became mountains. The mountains became worlds. This was the time of planet formation. A chaotic, violent, beautiful era. A time when the solar system was being shaped, day by day, collision by collision. The Earth that you and I know, the blue and green Earth, with oceans and forests and life, did not yet exist. In its place was something we now call Proto-Earth. A younger, smaller, hotter Earth. A glowing sphere of molten rock, only partly formed. Still gathering material. Still finding its shape. And Proto-Earth was not alone in its orbit. There was another world, sharing the same path around the Sun. A world about the size of Mars. We call it Theia. The name comes from Greek mythology. Theia was a Titan, the mother of Selene, the goddess of the moon. The name was first proposed in the year 2000 by an English geochemist named Alex Halliday. And it has been used by scientists ever since. But the world itself is much, much older than its name. Theia formed in a region of space we now call a Lagrange point. These are special places in any orbit where gravity creates pockets of stability. A small object placed in a Lagrange point will tend to stay there. It will travel along with the larger world, but at a careful distance. For a very long time, Theia stayed in its quiet corner of Earth's orbit. It grew. It gathered material. It became more and more massive, and slowly, its mass became dangerous. Computer simulations suggest that once Theia grew larger than about 10% of Earth's mass, roughly the size of Mars, its quiet Lagrange point became unstable. Gravitational pulls from the other young planets nudged it gently out of its place. Just a tiny push. Just enough. And then, slowly, very slowly, Theia began to drift. It drifted toward Proto-Earth. For perhaps thousands of years, the two worlds approached each other. The distance shrank. Their gravity pulled at each other more and more strongly every passing century. There was no warning. No sound. No alarm. Just two worlds drawing together through silent space. And then they collided. Approximately 4.5 billion years ago, Theia struck the Proto-Earth. It was the most violent event in our planet's history. It was almost the end of our planet's history. For decades, scientists believed the impact was a glancing blow, a sideways strike that ejected debris into orbit. But more recent evidence, published in 2016, suggests something more dramatic. The impact may have been head-on. A direct, full-mass collision. A new study from NASA Ames Research Center in 2023 even suggests that the Moon may have formed not over months or years, but in a matter of hours. Material from both worlds flung directly into Earth's orbit, gathering itself into a new sphere almost instantly. Imagine that. Two worlds ending. One world beginning. In the time it would take to fall asleep tonight. Theia, the Mars-sized planet, was destroyed. Its rocky outer layers, its mantle, were partly scattered, partly merged with Proto-Earth. Its iron core, the dense metal heart of the planet, sank slowly down into Earth's interior, joining with our own core. Some scientists believe that, deep beneath our feet, in the lowest regions of Earth's mantle, there are still fragments of Theia today. Vast blobs of foreign material. Continent-sized remnants of the world that once shared our orbit. Quiet ghosts in the dark. A study published in 2023 in the journal Nature suggested exactly this. Two enormous structures, deep inside the Earth, known to geophysicists as large low-shear velocity provinces, may be ancient pieces of Theia. Pieces that never fully melted. Pieces that have been resting in the deep mantle, untouched, for billions of years. You are standing on top of a world that once was too. The debris of the collision did not all fall back to Earth. Some of it spread outward, into orbit. A vast ring of glowing rock and vapor surrounded the wounded Earth. And within that ring, something began to form. Particles attracted other particles. The ring thickened in places. Gravity gathered the material. Slowly, or perhaps very quickly, if the new theories are correct, a new sphere took shape. A new world, born from the death of the old. That world was the Moon. The Moon you see tonight. The Moon that lights the seas. The Moon that has watched over every human who ever lived. The Moon in every poem, every painting, every lullaby. It is the child of a vanished planet. If Theia had not existed, if it had stayed quietly in its Lagrange point forever, there would be no moon. And without the moon, everything would be different. The moon stabilizes the tilt of the Earth's axis. Without it, our axis would wobble wildly over millions of years. The seasons would become unpredictable. The climate would shift. Ice ages and warm ages would come and go in chaotic patterns. Some scientists believe that without the moon, without Theia's sacrifice, life on Earth might never have evolved into what it is now. The slow, patient march from simple cells to forests, to fish, to dinosaurs, to us, might never have happened. We owe everything we are to a world that no longer exists. A world named after the mother of the moon. A world that drifted gently across the early solar system and then ended itself so that we could begin. Look at the moon tonight when you have a chance. Half of it is Theia. Now we will travel outward. Past Mars, into the empty space between Mars and Jupiter. This region is mostly quiet. Mostly dark. There are no stars here, the sun is just one bright point in a vast black sky. But there is something here. Spread across millions of miles of space, drifting in slow, ancient orbits, there are rocks. Millions of rocks. Tens of millions, perhaps. Some the size of pebbles. Some the size of mountains. Some the size of small countries. We call this region the asteroid belt. But for centuries, astronomers asked a strange question. Why is this region full of rocks, instead of full of a planet? Every other large region of the solar system has a planet. Mercury, Venus, Earth, Mars, each one in its own quiet orbit. Then a gap. Then Jupiter. Then Saturn. Then Uranus. Then Neptune. But between Mars and Jupiter, instead of a planet, there is only debris. Why? In the 1770s, a German astronomer named Johann Daniel Titius noticed a strange mathematical pattern in the spacing of the planets. Each planet, he claimed, sits at a predictable distance from the Sun. The pattern was later refined by another German astronomer, Johann Bode. Today, it is known as the Titius-Bode law. According to this law, there should be a planet between Mars and Jupiter. But there wasn't. For decades, astronomers searched. They watched the empty space. They calculated. They waited. And then, on the very first night of the 19th century, the first day of January, 1801, a small dot of light was found. It was given a name, Ceres. At first, astronomers believed they had finally discovered the missing planet. But Ceres was small. Far smaller than expected. Then, the next year, another small object was found. Pallas. Then another. Juno. Then Vesta. Soon, dozens were found. Hundreds. Thousands. Eventually, 1 million. There was no planet between Mars and Jupiter. There was a swarm. In 1802, a German astronomer named Heinrich Wilhelm Olbers proposed an explanation. What if these objects were the broken pieces of a world that once existed? What if there had been a planet between Mars and Jupiter, a real, complete planet, and something had destroyed it? Shattered it into 1 million pieces? Scattered its remains across the solar system? The hypothetical planet was given a name from Greek mythology. Phaeton. The name comes from the legend of a young man, the son of the sun god, Helios. According to the myth, Phaeton tried to drive his father's chariot, the chariot that carried the sun across the sky. He was too weak. He lost control. The chariot fell. And to save the earth from being burned by the runaway sun, Zeus, the king of the gods, struck Phaeton down with a thunderbolt. The planet was named for a destroyed son of the sun. A world that flew too close. A world that fell. For most of the 19th century, the Phaeton hypothesis was widely accepted. Astronomers imagined an enormous, complete planet, perhaps the size of Earth, perhaps even larger, orbiting peacefully between Mars and Jupiter for billions of years. Some imagined oceans. Some imagined continents. A few even wondered if Phaeton might have had life of its own. And then, through some catastrophe, the planet exploded. Or shattered. Or collided with something larger. And what was left became the asteroid belt. It is a beautiful story. But the story, in the end, may not be true. In the late 20th century, as our understanding of planet formation deepened, scientists began to doubt Phaeton's existence. The asteroid belt, when measured carefully, turned out to contain very little mass. If you gathered every asteroid in the belt and pressed them all together into a single ball, the result would be smaller than our moon. Far too small to be the remnant of a destroyed planet. A planet would leave more behind. The accepted explanation today is different and quieter. The asteroid belt, modern science tells us, is not the remnant of a planet that died. It is the remnant of a planet that never managed to be born. Jupiter, the giant gas planet just beyond, was simply too close. Too massive. Its enormous gravity disturbed the rocks and dust that were trying to come together in that region. Every time the small bodies began to merge, Jupiter pulled them apart. Every time they tried to grow, Jupiter scattered them. The planet that should have formed there never could. The asteroids are the rough draft of a world that was never finished. And yet, even now, the story of Phaeton has not entirely died. In 2018, researchers at the University of Florida proposed a new variation. They suggested that the asteroid belt may indeed be the remains of fragmented worlds, but not one world. 5 or 6 smaller, planetary-sized objects that came together and broke apart, again and again, in the chaos of the early solar system. Not one Phaeton. Many small ones. A whole family of unborn worlds, ground down into the asteroid belt we see today. So when you imagine the empty space between Mars and Jupiter, do not picture absence. Picture a vast field of debris. Picture the broken bones of worlds that almost were. Picture the Phaetons that never quite became a Phaeton. Drifting. Endless. Quiet. Spinning in slow, ancient orbits, in the cold and the dark, around a sun that hardly seems close at all. The story of Phaeton is the story of a world that may never have existed in the form we imagined. The next story is even stranger. It is the story of a planet that astronomers believed in for nearly 60 years. A planet whose orbit was calculated. A planet whose mass was estimated. A planet that was, supposedly, even seen by many observers in many places. A planet that had a name. A name still familiar to us today. Vulcan. To understand Vulcan, we must first understand a problem. In the early 19th century, astronomers had refined their understanding of the planets. They knew the planets followed predictable paths. The mathematics of Isaac Newton, published nearly 200 years earlier, could explain almost everything. The orbits of Earth, Mars, Jupiter, Saturn, all of them could be calculated, predicted, traced. But there was one problem. Mercury. Mercury, the smallest planet, the closest to the Sun, did not behave the way it should. The orbit of Mercury was slowly shifting. With every revolution around the Sun, every 88 days, the orbit moved by a tiny amount. Newton's mathematics could not fully explain this motion. There was a small but real discrepancy, a precession that nothing seemed to account for. In 1859, the famous French mathematician Urbain Le Verrier proposed an explanation. There must be another planet, a small, dark world, orbiting between Mercury and the Sun, so close to the Sun that its light was hidden by the brightness of the daytime sky. Invisible, but real. Pulling on Mercury, just enough to disturb its orbit. Le Verrier had reason to be confident. 12 years earlier, he had used the same method to predict the existence of Neptune. He had calculated the orbit of an unseen world based on the disturbances it caused to Uranus, and astronomers had then pointed their telescopes, and there it was. Exactly where he said it would be. He was, at the time, perhaps the most respected mathematician of orbital mechanics in the world. So when Le Verrier said there was a planet between the Sun and Mercury, the world believed him. He gave the planet a name: Vulcan, the Roman god of fire, the god of forges and volcanoes. A fitting name for a small, hot world, baking in the unbearable heat of the inner solar system. And then, something remarkable happened. People began to see it. A French amateur astronomer named Edmond Modeste Lescarbald claimed to have seen Vulcan crossing the face of the Sun in March of 1859. Le Verrier studied his report. He calculated the orbit. He published the result. Other observers around the world also reported sightings. Small dark dots crossing the bright disk of the Sun. Each sighting added confidence. Vulcan was real. Vulcan existed. We had found it. For more than 50 years, astronomers searched for further confirmation. They watched the Sun during eclipses, when the bright disk was hidden by the Moon, in case a small, dark planet might be glimpsed nearby. They built bigger telescopes. They studied old observation records. And yet, Vulcan was never definitively confirmed. The sightings, when reviewed carefully, turned out to be other things, sunspots, perhaps, or distant asteroids passing through the field of view. Each report could be explained without needing Vulcan to exist. Astronomers grew uncertain. The planet that had been so confidently announced began to fade. And then, in 1915, something changed everything. A young physicist in Berlin, named Albert Einstein, completed a new theory. A theory of gravity. A theory that built on Newton, but also corrected him, at extreme conditions, near very large masses, like the Sun. Einstein's general theory of relativity made a prediction. The orbit of Mercury, Le Verrier's stubborn problem, should precess by a very specific small amount, simply because of the way the Sun's gravity bends the fabric of space and time itself. The amount Einstein predicted matched the observations exactly. There was no Vulcan. There never had been. Mercury's strange orbit was not caused by an unseen planet. It was caused by the curvature of space itself, by the deep, gentle warping of reality near a star. Le Verrier had been wrong. Not because his mathematics were poor, but because he was working with the wrong physics. The universe, as Einstein revealed, did not need an extra planet to explain the motion of Mercury. The universe simply needed to be seen more deeply. And so, in that quiet moment in 1915, Vulcan died. A planet that had lived in textbooks. A planet that had appeared in lists of solar system bodies. A planet that astronomers had searched for with telescopes for half a century. It vanished, gently, into the past. Not destroyed. Never broken. Just never there at all. Today, the inner region of the solar system, the space between Mercury and the Sun, is mostly empty. There are no large planets there. There are not even, despite some hopes, any sizable asteroids. A small group of bodies, called Vulcanoids, has been theorized to perhaps still exist, but searches have failed to find them. Vulcan was a beautiful idea. A ghost planet. A world that lived only in our minds. A world born of our hunger to understand. And when understanding deepened, the world quietly faded, like a candle blown out at dawn. It is strange to think, but the story of Vulcan is also the story of how we changed. Once, we needed an extra planet to explain the universe. Then, we needed only deeper mathematics. The universe did not change. We changed. And Vulcan is the name we gave to the gap between what we understood and what was true. The solar system has known many lost worlds. Some have famous names. Theia, Phaeton, Vulcan. But there are others, smaller, quieter, less well-known. Worlds that have been suggested, proposed, sometimes named, sometimes searched for. Worlds that may have existed, or may have been imagined, or may still, perhaps, be hiding. Tonight, let us walk softly past 5 of them. The first is called Planet V. In the early 2000s, 2 American astronomers, John Chambers and Jack Lee Sauer, were running computer simulations of the early solar system. They were trying to understand a strange period in its history known as the Late Heavy Bombardment. A time, about 4 billion years ago, when the inner planets were struck by enormous numbers of asteroids and comets. The impacts left scars on Mercury, Venus, the Moon, and Mars. Scars that we can still see today. But what caused the Late Heavy Bombardment? Why did so many asteroids suddenly find their way into the inner solar system, striking the young worlds again and again? Chambers and Lee Sauer ran their models. And they found something interesting. If you place an additional planet, slightly smaller than Mars, between Mars and the asteroid belt, the simulation matches the observations almost perfectly. The orbit of this 5th world becomes unstable over hundreds of millions of years. It begins to wobble. It begins to swing closer and closer to the asteroid belt. And eventually, it disturbs the orbits of countless asteroids, sending them tumbling inward toward the rocky planets. This hypothetical world, they called Planet V. It would have been a small, rocky planet. Perhaps the size of our moon. Perhaps slightly larger. It may have had a thin atmosphere. It may even have had its own small moons. In the simulation, after disturbing the asteroid belt, Planet V is itself thrown out of the solar system. Or it falls into the Sun. Or it is destroyed in some final, violent collision. Whatever happened, by the time the dust settled, Planet V was gone. It is only a hypothesis. Other models can produce similar results without it. But Planet V remains a quiet possibility. A small, vanished world that may have been responsible for some of the deepest scars on the Moon. The second lost world is called Krypton. Yes, like the home world of Superman. The name was deliberately chosen. In the 1970s, a Canadian astronomer named Michael Ovenden proposed a new variation of the old Phaeton hypothesis. He calculated that the planet between Mars and Jupiter, if it had once existed, might not have been a small, rocky world. It might have been enormous. A gas giant. Almost the size of Saturn. Perhaps 85 to 90 times the mass of Earth. He named it Krypton, after the destroyed home of Superman in the comics. Like Phaeton, Krypton has been ruled out by modern evidence. The asteroid belt simply contains too little mass for such a large planet to have existed there. But Ovenden's idea is still beautiful, a gas giant in a region where, today, only dust drifts in silence. The third lost world has no formal name. It is the proposed second giant impactor, sometimes called Theia's twin. In the 2012 hypothesis, by an American astronomer named Robin Canup, the Earth-Moon system was created not by one impact, but by two. According to this model, two large planetary bodies, each larger than Mars, collided. Their collision was so violent that they merged briefly into a single, glowing, donut-shaped cloud of vaporized rock, a body called a synestia. From within that cloud, both Earth and the Moon eventually emerged. If this hypothesis is correct, then Earth itself is the daughter of two lost worlds. Two ancient planets, each gone. Both of them, still here, mixed into our oceans and our continents. We are walking on their bones. The fourth world is more recent and less certain. In 2023, scientists discovered two enormous structures deep within the Earth's mantle. These regions, known as large low-shear velocity provinces, sit thousands of miles beneath our feet, near the boundary between the mantle and the core. They are continent-sized. Strange. Different from the surrounding mantle in ways that have puzzled geophysicists for decades. A new theory suggests they may be the remains of Theia. Pieces of the world that struck the Earth 4.5 billion years ago. Pieces that never fully mixed in. Pieces that have remained, undisturbed, in the deep dark of the Earth's interior, for the entire age of life on this planet. Two ancient ghosts. Resting deep beneath every step you take. And the fifth is the strangest of all. It has no name. It has no fixed location. It may not even be a single world. It is the population of vanished planets, sometimes called planetesimals, that astronomers believe must have existed in the early solar system, but that left almost no trace at all. Models suggest there were many. Mars-sized. Moon-sized. Some larger. Dozens, perhaps hundreds, of small worlds. They formed quickly. They wandered. They collided. They merged. They were thrown out into interstellar space. Most of them are gone. A few may still be drifting, alone, in the darkness between the stars. Cold worlds with no sun. Frozen forever. Orphaned. Astronomers have begun to find such bodies, not in our own system, but in the vastness beyond. They are called rogue planets. Worlds without stars. Some of them, perhaps, were once ours. We sent them out, long ago, in the chaos of our solar system's birth. They are still traveling. Somewhere, far away. Going nowhere in particular. Going on forever. We have spoken of worlds that died. Worlds that shattered. Worlds that never truly existed. Now, at the very edge of our solar system, far beyond Neptune, in a region of cold so deep that the sun is barely visible, there may be one last lost world. A world that has not been found yet. A world that we are still searching for. If it exists, we call it Planet 9. The story begins in 2014. Two astronomers, Mike Brown and Konstantin Batygin, at the California Institute of Technology, were studying the orbits of small icy bodies far beyond Neptune. These bodies, called trans-Neptunian objects, drift slowly through the outer darkness, taking thousands of years to complete a single orbit around the Sun. Brown and Batygin noticed something strange. The orbits of these distant objects were not random. They were aligned. Several of the most distant bodies all had elongated, oval-shaped orbits. And the longer axes of those orbits, the directions they pointed, were strangely clustered together. As if some unseen gravitational hand were pulling them all gently in the same direction. Brown and Batygin ran the numbers. They calculated the odds of such an alignment occurring by chance. The odds were extremely low. Less than 1%. There was, they concluded, almost certainly something out there. Something massive. Something pulling on the orbits of these distant icy worlds and shaping them into a quiet pattern. A planet. A real, substantial planet, perhaps 5 to 10 times the mass of Earth. Perhaps a small Neptune. Perhaps a super-Earth. Orbiting the Sun at a distance of perhaps 400 to 700 times the distance of the Earth. So far from the Sun that a single orbit would take 10,000 years to complete. So far that the Sun itself would appear as just one bright star, among many. So cold that the surface would be eternally frozen, never thawing, never warming. If Planet 9 exists, it is a slow, dark, lonely world. A world that has been moving in its enormous orbit since long before humans walked the Earth. A world whose year is longer than the entire history of human civilization. Astronomers have searched for Planet 9 for over a decade now. They have looked carefully through deep sky surveys. They have mapped enormous regions of the outer sky. They have used some of the most powerful telescopes on Earth and in space. So far, they have not found it. But they have not given up. The new Vera C. Rubin Observatory, built in the mountains of Chile and beginning operations in this decade, will be powerful enough to find Planet 9, if it exists. It will scan the entire visible sky every few nights, for 10 years. If Planet 9 is there, the Rubin Observatory will likely find it. Or it may not. There is always the possibility that Planet 9 does not exist at all. Some scientists have proposed alternative explanations for the alignment of the distant orbits. Perhaps the patterns are due to observational bias. Perhaps they are due to other small, undetected gravitational influences. Perhaps they are not really patterns at all. And there is one final, strange possibility. Some researchers have suggested that Planet 9 might not be a planet in the usual sense. It might be a primordial black hole. A small, ancient black hole, left over from the very beginning of the universe, captured by the Sun's gravity billions of years ago. It would be massive, but tiny, perhaps no larger than a grapefruit. Invisible, except for its gravitational pull. Drifting through the darkness beyond Neptune, swallowing the occasional comet, otherwise silent. We do not know. We do not yet know. Somewhere, perhaps, Planet 9 is moving slowly through the dark cold. Right now, as you breathe. Right now, as you rest. It does not know we are searching. It does not know we exist. It moves on its long, patient orbit. It is, perhaps, the last lost world of our solar system. The world we have not yet found. The world that is still waiting. We have come to the end of our journey. We have walked among lost worlds. We met Theia, the Mars-sized planet that gave us the Moon, and whose remains may still rest beneath our feet. We met Phaeton, the imagined planet between Mars and Jupiter, now believed never to have been whole. We met Vulcan, the small inner world that astronomers believed in for 50 years, before Einstein gently revealed it had never existed at all. We met Planet V, and Krypton, and the synestia of Earth's birth, and the deep mantle ghosts, and the uncounted vanished planetesimals of the early solar system. And we met Planet 9, the last quiet possibility, drifting at the edge of everything, perhaps real, perhaps not, perhaps still waiting to be found. Each of these worlds tells the same quiet story. The solar system is not what it once was. It has lost worlds. It has shed worlds. It has imagined worlds. It has, perhaps, hidden worlds. We, the living things of Earth, are the lucky inheritors of what was left behind. The Moon is our companion, because Theia died. The night sky is full of patterns, because the planets that survived are the ones that found stable paths. The water in our oceans, perhaps, came from comets and asteroids, fragments of worlds that never quite were. And the very iron in your blood, the calcium in your bones, all of it was forged in stars that themselves died long before the Earth was made. You are made of dead worlds. You are the small, breathing memory of vanished things. There is a quiet truth in this. The cosmos does not last. Worlds end. Stars die. Galaxies fade. Even the faraway empty space, in unimaginable trillions of years, will grow colder and quieter and slower. But none of that, tonight, has to disturb you. Tonight, the universe is here. The Moon is here. The stars are here. The lost worlds are remembered in the soft mathematics of orbits and in the gentle stories we tell. You are here too. Breathing. Resting. A small, warm, living thing on a small, warm, living planet orbiting a small, warm, living star. For now. That is enough. Sleep well. The cosmos keeps watch. Good night.